The idea is to basically integrate with all different parts of the stack. So that's kind of the first thing that our customers do, and that Monte Carlo does. It's connect to the data warehouse, to the data lake, to orchestration tools, to BI tools, really, and collaboration tools as well. So really anything that our customers use to do their job.
Lior and Barr, welcome to the show.
Thanks so much.
Hi, Sean.
Yeah, thanks so much for being here. I'm very excited to talk about data observability, Monte Carlo. But maybe before we get there, let's kick things off with an introduction. Who are you? What do you do? And how did you get to where you are today? And Lior, maybe we'll start with you.
All right. So my name is Lior. I'm a co-founder and CTO at Monte Carlo. Before Monte Carlo, I actually founded another startup, a cybersecurity startup. That startup ended up being acquired by a company called Barracuda, where I ended up leading the engineering team and building products that help people basically protect themselves from fraud. How I ended up starting Monte Carlo alongside Barr was basically we were using machine learning and analytics to do some fraud protection work that could be done before with kind of more traditional rule-based techniques. We built some innovative products that were widely adopted and protected millions of people. However, when I thought about, the times that we disappointed our customers where we didn't deliver on our promise, I realized that it was more frequently because of the data side of the house, right? The parts that drive machine learning and analytics that were so core to these products, and not so much the more traditional kind of infrastructure and application side, which, and when thinking about it, I basically realized, hey, I'm of a software engineering background, and so was most of the team, and there's some good ways to work on making your product reliable and kind of work the way you expect on the software engineering side. We generally call it DevOps, right? And so we had the methodology, we had the tooling, but all of that did not exist on the data side, right? When you're creating a machine learning model and running it, or when you're creating analytics and you're driving your application with data, there were no well-established ways to make sure those systems were reliable and the data was right. And that hit us again and again. And so that was some of the inspiration to create Monte Carlo, which helps data teams make their data reliable and trustworthy. We'll talk more about that, but I'll stop here.
Awesome. Yeah. And Barr, do you want to go?
Yeah. So I'm Barr. I'm the CEO and co-founder of Monte Carlo. Prior to Monte Carlo, in the last decade and a half or so, I've been in data and analytics, working with teams to help make decisions and build products with data. Prior to Monte Carlo, I was at a company called Gainsight, where we helped use customers or organizations use data to make decisions about their customer base. So think about, who's likely to churn, who's likely to upsell, why, kind of using data to drive sort of better processes and organizational behavior around that. And I was the person responsible for the data, and the data was wrong all the time. And I would wake up on Monday morning to a barrage of emails and complaints from various folks asking, WTF, is the data wrong? As a data person, I was really frustrated that the solutions were only, very manual. And when I was looking at my engineering counterparts, they had all these fancy solutions and I had none. And that pissed me off. And so decided to start Monte Carlo to solve that. I'm originally born and raised in Israel, so moved to the Bay Area about 15 years ago.
Oh, fantastic. Yeah, I think, the data quality issue that you mentioned, you always hear when it comes to things like machine learning, of course, that, you're basically the model that you build is very reliant on the quality of the input and the quality of the data. And in, the world of sort of typical software engineering, we have all these kinds of, tools for both observability and reliability, things like Datadog, PagerDuty, but we haven't typically seen as many of that tooling available to the data teams. So do you think that's a product of just the field of data engineering being at in a less mature state than regular sort of software engineering?
Yeah, it's a great question. I can chat a little bit about sort of some of the changes that we're seeing in data that we've seen. So, I would say if we go back 10, 15 years ago, maybe 10 years at this point, data was really confined to one or two people in the organizations who were trying to mostly count how many customers they had, or how many products they were selling. By the way, counting is still the number one problem, which we have not solved to date. If anyone can solve that, let me know. But that's really what folks were trying to do. Those people were oftentimes maybe in the IT organization, maybe in the finance team, and they had a lot of time to look at that data because they were using that data maybe once a quarter to report to the street or something like that. That is a vastly different world from where we are today. Today, you have hundreds, thousands of people using data. That data resides in various places. You might have multiple data warehouses, multiple data lakes. You will have multiple use cases for that data. And you might be using that data every single day, multiple times a day, maybe near real time in some situations. And so there's this evolution that we've gone as a data industry for how we use data, for what we do with data, and also the stakes for data. So if in the past it was a couple of people making very little decisions based on it, today people have their entire organizations and their products run based on those data. And we see this with the explosion of data products going from a term that's hardly been used to something that every organization is orienting themselves around today. How do we actually build and support data products? Ranging, from companies like JetBlue, who use data to power, our airlines, and where's your luggage? To organizations like CNN and New York Times, media organizations who are powering, their advertising or marketing with data. To B2B companies like PagerDuty and Gusto actually use data to power their customer relationships. That is a very different world than what it was 10, 15 years ago. And so even the definition of quality and what it means to have high quality data 10 years ago is not the same as today. And the stakes are way higher. So I think because of all of those reasons, it's become way more important to make sure that the data is reliable and trusted. And it's become something that's more sort of front and center. It's funny. I was talking to data leader a couple of days ago, and they were telling me, like 10 years ago, I had like 30 people staring at the data every single day to make sure that the report that we're sending to our CEO is 100% accurate. Like literally, I would hire people just to stare at the report. Today, I can't do that, right? Especially in this market. I need to find automated ways to help make my team more efficient.
Yeah. So you mentioned this. There's been essentially an explosion of the amount of data available to companies over the last 10 to 15 years, and then so essentially companies have access to way more information than they ever had previously, and they're storing and processing all that information, and that impacts the way that those companies make decisions. But what are some of the problems that companies run into with managing large amounts of data? You mentioned essentially data reliability, but maybe you can dive a little bit deeper into what are some of those sort of engineering problems they're going to run into when they're trying to actually utilize all this information that they're storing.
Yeah, absolutely. So as you mentioned, the amount of data is increasing. And as Barr mentioned, also the number of consumers and data products that are created from this data is increasing, because that's how you get value out of it, right? You put it in front of people or in front of models, or use it to power business processes, right? And so the complexity of the systems that are ingesting and processing and then serving that data has increased exponentially. And with that come a bunch of different challenges. I'll just name a few. Data discovery is a challenge. Like if I need to answer a certain question with data, where and how do I find the relevant pieces of information? That becomes really tricky. Access management, like how do you make sure that people that need the data get access to it, but people that don't need it don't? How do you manage privacy? How do you make sure that the right information gets to the right people? How do you find ownership? Like who owns what part of this system and who's accountable to make it work? Defining interfaces between different teams that are using the data or processing it. All these problems rear their ugly heads. These are all problems that will sound very familiar to software engineers, right? Because I think the growth in software engineering happened probably, a decade or two before data engineering. So like, there's good analogies there. Probably the biggest challenge, at least, we're biased, but the biggest challenge from our perspective at the end of the day is data trust. Like, how do you make sure that those data products that companies put either in front of their customers or in front of internal stakeholders, or again as input to kind of critical business processes, how do you make sure it actually works and is trusted? That has a bunch of different components. One of them is creating transparency, like where is this data even coming from, who created it, and how. And then there's what we traditionally talk about in reliability, right? In DevOps, there's kind of making sure the system is operating well, and that's where we focus, and that's where there's a lot of issues that come from various different directions, right? You can have your data sources changing in unpredictable ways. You can have people committing code to the data pipelines and changing them with unintended consequences. And you can have your infra failing in various different ways. And so managing that complexity of people and systems is a huge challenge. And that's kind of where we spend most of our time.
Mm-hmm. And then how are companies like dealing with these problems today, around data trust and data reliability? Are they essentially trying to build their own like bespoke solutions to this?
I could kick us off. So I think we've seen a variety of different ways. Of course, there's people who do nothing and pray, and that's increasingly not a sustainable path. I think in terms of approaches, where most people start is with what we call data testing, which is and there's some great tools out there to do that. It's basically it's the equivalent of unit testing in software engineering, right? It's the idea of adding simple validations to your data pipeline. So as the data flows through the pipeline, it will get validated, and the tests will make sure that it meets certain assumptions or invariants that the person who built the pipeline believes should be true, right? It could be things like, make sure this column doesn't have nulls, or make sure this field is present in a table, and various other kind of logical constraints. And this is where most teams start, and this will get you pretty far. What happens though is that as teams grow, as the complexity of the system grows, it becomes increasingly intractable to maintain your testing suite, right? And again, every software engineer knows that unit tests are critical, but it's not the only quality gate that you have, right? You have to do a bunch of other different tests, and you have to monitor your system in production, because you're not going to be able to write a sufficient number of unit tests with enough coverage to ever detect all issues. Not to mention the fact that it doesn't account for the integration part of the problem, right? And so as teams grow, they will start adopting additional tools on top of data testing and obviously data observability. is what we believe is a prime choice. And increasingly, we've seen great adoptions. By now, we've worked with hundreds of customers. Data observability adds a layer of essentially monitoring, and we'll talk about what observability adds on top of monitoring, but basically monitoring your production data system, so your data warehouse, your BI tools, your orchestration tools, your data lakes, and kind of making sure that the system works as expected and that your data products are reliable in production, right? So it's basically monitoring the aggregate effect of the code that you have, the data that you're ingesting, and the infrastructure that you're running on to make sure that the end product is reliable. And alongside the data observability tool, people also adopt, an operational cadence or an operational discipline around it, and an incident response process, and sometimes ownership around what components of the data system are owned by whom. So it kind of really drives, a regimented way to make sure trust and reliability are there.
So you mentioned, essentially monitoring and data observability. So who within an organization is typically responsible for sort of owning the monitoring and observability of these data pipelines? Is that going to fall into the responsibilities of the data team?
So absolutely. So that's such a great question because we're seeing a shift there. It's traditionally I talked about all the different challenges that exist around managing vast amounts of data. Traditionally, you had people in the organization who's usually they would be called data governance people, and their job was to basically layer over governance on top of the data stack, right? Add quality and trust and discovery and all those other parts of the governance challenge, right? We're seeing things shift as we saw them. Again, this is reminds me so much of software engineering, but you used to have ops teams that would be completely independent of software teams, and that didn't really work great. And then we started embedding that function within engineering teams, right? DevOps, right? So you have to work pretty closely with the team that builds it in order to make the thing reliable or secure or whatever it is. And we're seeing that happening in data teams as well. So basically, data teams are taking ownership. We're seeing, data engineers, analytics engineers, analysts taking ownership of making sure that what they're building, what they're delivering to their customers is reliable rather than having a separate group of people and a separate function taking care of that.
And I would add, I think it's sort of a reckoning moment for data teams, if you will. If you think about, what we've done in the last decade or so as a data industry, data teams basically made history as one of the very first departments to spin up 8-figure technology stacks with really little to no questions asked. And one of the prime reasons why they can't see or are struggling to see ROI on that is because the data is inaccurate, can't be trusted, and can't be used. And so data teams are put in a position where we have sort of top-notch, world-class, best tech stack that we can. Now it's money time. We need to make sure that we can use that data to actually drive impact. And so that, I think, where a lot of the questions around how do we do that in a scalable, automated, proactive way is where we can rely on best practices from software engineering. It's all, we don't want to reinvent the wheel. There's been sort of a lot of advancements in DevOps that we can adopt here that I think we're seeing data teams rely on.
Yeah, and you made this analogy or connection to software engineering teams a couple of times. You see, since we have this explosion of data, and then now, like you said, that this it's ROI time for businesses. Do you think we'll also see essentially a continuation of specialization within data teams, where we're going to have essentially the equivalent of a DevOps or type person within data teams? So maybe, I don't know, data DevOps or so, something like that. We need to work on the branding, but essentially, as these areas become more important to a business, there's more people in those industries, you end up with a specialization. Is that something you're starting to see as well?
100%. I think both, to Lior's point earlier, there's a lot of shift in the data roles themselves, whether it's data governance, data analytics, machine learning engineers, analytics engineers, sort of a plethora of titles today. We're also seeing more and more specialization in sort of teams that are responsible specifically for the reliability of data, for the security of data. There we're starting to see teams that are called basically DRE, so as SRE, data reliability engineers. We're seeing more and more of that in job descriptions, actually. So it's quite interesting, and I do see kind of a following in terms of the titles and roles as well.
Yeah, it is interesting. So we've touched on a bunch of issues here, and also I think on the need of some sort of platform essentially that helps teams around managing the data reliability. So I think this brings us to a good place to talk a little bit about Monte Carlo's platform. So can you start by just explaining how Monte Carlo helps organizations improve their approach to data quality and reliability?
Yeah, absolutely. So actually, Datadog is a great analogy for what Monte Carlo is, and quite frankly, it inspired a lot of knowing Datadog and New Relic really inspired a lot of what we did at Monte Carlo. And so if you're familiar with Datadog, it's very, very similar. The idea is to basically integrate with all different parts of the stack. So that's kind of the first thing that our customers do, and that Monte Carlo does. It's connect to the data warehouse, to the data lake, the orchestration tools, to BI tools, really, and collaboration tools as well. So really anything that our customers use to do their job. And then we basically collect metadata and metrics and logs from all of these systems and create a unified view of the health of the system, of the health, and more importantly, the health of the data that's flowing through the system. And that essentially powers three different use cases that are critical in the DevOps or / data ops process, right? The first one is basically being able to know that you have an issue, right? Alerting people proactively when something breaks. So that's really probably the most important value that you get out of Monte Carlo is we take all this information and we can automatically create alerts on Slack or whatnot that tell people like, hey, something's broken. So instead of getting an angry Slack message from the CEO, you're getting an angry Slack message from us, which is much better. The second part where we see ourselves helping is in triaging and troubleshooting and then resolving those issues, right? When you have a problem, as we said, data systems are very complex. A lot of things can go wrong. It could be the data, it could be the code, it could be the infrastructure. And so we give people a complete view of all these different parts and let them essentially correlate all these things in order to understand what the root cause of the issue is, right? And we can talk more about it later, but that is actually a critical component. We see this time and time again with monitoring tools. They're really focused on the first part of the problem, kind of detecting and sending people alerts. What ends up happening is a lot of fatigue, right? Because people get alerts and then there's like some obscure issue in the data, and then it can be so tedious to understand what happened that people simply ignore these and go back to to status quo, pre-observability. Where we really try to shine is giving people all this context about what happened, where it happened, what are all the different factors that could have led to the issue. And then the kind of final use case that we also really like to help our customers with is preventing data issues, basically helping them mitigate some of the issues that might happen in the future. And we do that by giving them insights about how their system is structured. We help them understand the different dependencies between all the different pieces that they have. In particular, we automatically create, field level lineage across the entire data stack. That works kind of out of the box, which allows people to better understand how changes in their system are going to impact, other parts of the system. We give people a lot of analytics about how data is used, how their data stack is performing, and a lot of other information that really helps them make wise decisions and actually improve the system over time, so that not only do they get alerted quicker and solve the problems faster, which kind of deals with the time to detection, time resolution problem, but also are able to reduce the number of incidents that they have in their data. I'll maybe give a very simple example, but and this has happened to anyone who's building stuff with data. One day, you wake up and an obscure field in one of your data sources becomes a null, right? You're suddenly getting nulls instead of IDs that are really critical for you. And so in that kind of scenario, Monte Carlo can basically automatically detect with almost no guidance that this has happened, right? It will detect that, a certain column that used to have values now has nulls. It will send a Slack alert to the right team, right? We actually are able to find the right owners for that problem. We will have all the information about what happened. And the person triaging it would be able to look at the table, where that data is coming from, what changes recently happened to the code that is creating that data, easily navigate to code changes that maybe happened upstream, understand the data sources that are feeding into it, also understand the downstream dependencies. Like, is this something that actually matters? Is anyone using this? Who needs to be informed on the status page, right? And people oftentimes neglect that. But when you're talking about trust, about creating trust in data, it actually matters if you're able to proactively let people know, hey, something's broken, I'm working on it, versus they find out on their own, right? So we create a complete solution for that entire workflow around getting alerted on and solving and communicating around data incidents.
So in going back to your example there, where you're detecting that a null value suddenly is entering this field, how does Monte Carlo know that is not the right thing to be doing? Is it doing some sort of like pattern recognition, or is that a predefined rule that has to be set up?
Such a great question. The answer is both. So we give our customers the flexibility to define rules and thresholds and logic where it makes sense for them, where they have very, very strict requirements. But what really helps Monte Carlo customers scale is the fact that we automated a lot of it with basically with machine learning, right? And we have the advantage of having access to the data, and so we can actually look at past patterns of that data. And in this particular example, we might observe that this column historically has 100% of the values populated, and those values meet a certain pattern, etc. And then as we observe the system and see new data coming in, we might see that has shifted quite a bit, right? That metric in this particular case, the null percentage, shifted from being 100% to less than that. And that's something we can do with kind of anomaly detection algorithms that we built at Monte Carlo. We can basically compare the current behavior to what the past predict behavior should be, and alert when there's deviations. And essentially, the kind of secret sauce here, if you will, is that By now we have quite a bit of scale. We help thousands of data engineers, deal with these incidents every single day. And all these people are providing very valuable feedback to us. So our system actually gets better and better with every day that passes. And so we were able to start from, a very basic system to a system that's now highly refined, and it's getting better every single day. And then there's additional things we do to further automate and scale the thing, which is to basically combine these past patterns that we see with metadata and lineage and end-to-end visibility, right? I'll give an example of how it plays out. Typically when data breaks, a lot of things happen, right? It might manifest if a certain table has nulls in it, those nulls might propagate to downstream tables, or even change them in other kind of unforeseen ways. And that will create a lot of alerts, right? You might get dozens of alerts in certain cases about the exact same problem. And so the way we help teams deal with that is we're actually able to group and correlate all these alerts and tell customers like, hey, all these tables, they're actually related by lineage, right? By dependencies and by transformation. And they actually maybe even have the same owner. And so we're able to really create, to reduce noise there, and also help people pinpoint the problem rather than trying to deal with 50 different alerts about different things. And so there's a lot of work that went into scaling the data quality challenge so that you don't have to configure everything on your own and you don't have to figure out problems all on your own.
Consolidation of the alerts makes a lot of sense, because I think if you end up bombarding somebody with a lot of alerts and noise, then it goes back to like what you're saying is someone just gets overwhelmed and it's like, well, I'll just ignore this, and then you're back to the like a real problem of basically no monitoring. So I suspect in terms of this like anomaly detection work that you're doing, I imagine your background in fraud detection, some of the learnings that you had there has been sort of transferable to this, because it's a lot of kind of like same sort of pattern recognition and stuff. Do you end up having to create essentially a different model of behavior for every, field of data, if we're imagining sort of like a schema-based database or something like that?
Yeah, great question. So the answer is yes. We basically train a model per metric that we collect. And so our models are really tuned for every customer, but also every single table and metric that they have. Of course, there are learnings that we apply across the board. We obviously don't use data across customers, but we're actually able to use the feedback that people provide in the context of their own system to really make the model learn and fine tune itself for every specific customer and every specific table.
So in terms of the feedback loop, that is, someone's actually able to say like, this is like essentially like useful, or this is accurate or not. And then you take that into account for adapting the machine learning that's driving these alerts and behaviors.
Absolutely. Yeah.
So you mentioned earlier that when you were first describing sort of how Monte Carlo works, that you're connecting throughout the stack as a user of the platform. So can you talk a little bit about like, how does someone go about like integrating Monte Carlo into this, existing data infrastructure and maybe a variety of tools that the organizations are already using?
Yeah, absolutely. So I'll give a generality and then I'll give some examples. But in general, we use the APIs that these systems provide. So the integration process is actually fairly simple. You don't need to add anything to your code or install agents or anything like that. You basically create or read-only credentials to all the different parts of the stack. And we pull everything we need from there. So to give you an example, if you're connecting Monte Carlo to Snowflake or Redshift or BigQuery or Databricks, you'll be creating or read-only users. We have obviously SQL snippets that automate it. And then you'll basically punch these credentials or these API keys into Monte Carlo, and then you go from there. We do all the rest. We never pull data out of these systems. We just use them to query the data. That's really critical from a performance and also security and compliance standpoint. But we don't need customers to move the data into Monte Carlo or to wire their pipelines. We automate all of that.
I see. And then because you're querying into these existing data sources, is there any impact from a performance standpoint to add this level of observability?
Great question. The TLDR is, yes, there is impact, and yes, and it's minimal. And I'll explain. And that really differs between the different technologies. For example, with Snowflake, you won't see any performance impact because it's pretty easy to separate workloads. But you will see a cost impact. On the other hand, on Redshift, there's no separation of workloads, so you won't have cost impact, but you will have a performance impact because we do query those systems. We've done a lot of work to make sure that the impact is minimal. So basically, for most of our customers, you'll see a low single-digit percentage increase in cost or kind of performance degradation. And we've invested a lot in doing that. Obviously, you don't want your observability tool to be a major spend or hurt the workloads. And so we invested a lot in scaling, doing everything incrementally, and doing everything very, very efficiently in a very optimized way. We use metadata extensively wherever we can to do certain things that you could have done with data, but metadata is cheaper to extract, right? So we've definitely paid a lot of attention to that. We definitely don't want to harm the system that we're observing.
Mm-hmm. What has been sort of like one of the biggest like technical or engineering challenges that you've had to work through in order to build a platform like this?
Great question. I think probably, so we talked about the anomaly detection piece, which is far from trivial. I mentioned we automatically generate lineage, which is a really, really interesting technical challenge because it requires a lot of reverse engineering of logs and metadata from various systems. But probably the biggest challenge is that we support a variety of different tools. I think we now support several dozen tools across these different categories. And we go pretty deep with those tools, right? Like when we build an integration for a certain warehouse or for a certain BI tool, we deeply understand its objects and its metrics and its metadata. And so we've really had to create, yet from the standpoint of the end user, you get a pretty streamlined and consistent experience, right? It doesn't matter what data warehouse you use or what orchestration tool you use or what BI tool you use. You get very consistent workflows and very consistent capabilities. In order to do that, we really had to create basically a common data model for all these different tools, and that is both rigid enough so that we can build all these capabilities and all these applications on top of it, but also flexible enough to account for, a variety of different tools that work in very different ways. And getting to that sweet spot was definitely both challenging but also very gratifying, and and critical to our success.
Yeah, it sounds like there's several sort of components of that challenge. First, you have to build this like deep expertise in with whatever data source that you're sort of hooking into. Then you also need to create like a really great sort of frictionless user experience so that people aren't like having to learn something completely new every time they're connecting like to a different source. And then on top of that, you're creating this abstraction layer of the data that needs to be able to be consistent across all these different data sources, but powerful enough to actually do all the observability and various other tooling that you provide. That's a lot of, that's a big hairy mess to try to work through. But essentially that is the value that I guess that you're bringing to these companies. So one of the things you mentioned was, clearly if you're using this, there's, maybe some little bit of performance hit that someone's taking depending on the source of data. And then on top of that, it might increase their costs because of, the increased compute or queries that are running. But what is the sort of like ROI that companies are getting by where they're, willing to accept essentially those downsides in terms of the value that they're getting out of adding this level of observability and knowing when actually there is a problem with the data?
I can start with the business impact, and then Lior, maybe you can chime in on sort of engineering workflows. I think, on the business impact, I'll just give a couple examples to bring to life what happens when things go wrong. So a couple examples sort of from the news from recently. Unity is a gaming company that published that because of one schema change, Lior spoke earlier about sort of changes that engineering teams might make or other upstream organizations. So for Unity, they were using data to power some of their ads, and one schema change actually resulted in a mistake that cost $100 million. And so you can imagine the ROI and that issue, right? And organizations, data teams have issues not once a year. They have issues daily often. Data teams spend, 30 to 80% of their time on fire drills. And so when the cost of one issue is so significant, you don't really want to risk that, right? And we see that across companies that we work with, right? So it's not uncommon for one kind of data issue to have significant impact on revenue. Another example that I think helps bring this to life is Equifax, sort of a credit score company, released a couple months ago that they actually issued wrong credit scores to millions of users because of actually a problem that they had with the data feeding one of their algorithms. And so, sort of the social economic, implications of that, millions of users that can't take out a loan or a mortgage as a result, like those are sort of real lives that are being impacted in that sense. And so, I think data teams have more and more sort of power and responsibility. And the cost of not being responsible with your data trust and data reliability is incredibly high.
Yeah, and I think just complementing it with, from the standpoint of the builders, of the people that build these systems, Barr mentioned this, they spend 30 to 80% of their time doing fire drills. If you can if you can reduce that, if you can make their lives easier and do this faster, there's a significant increase in productivity for these teams, right? And we people, I can't speak of our customers, but like people that joined Unity for that matter, or Equifax, they want to work on gaming, right, engines. Or they want to work on, on credit scores. They don't want to work on quality, and it's not the core business, right? So if we can free up these people's times to work on their core business, that is something that's very valuable, especially when you consider how scarce talent is and how expensive it is.
Yeah, absolutely. I think that's a consistent theme that we see in a variety of interviews that I've done with various people building tools, developer focused tools or data engineering focused tools, is let's get people back to doing the thing that they actually like to do and want to do that delivers value to the business, rather than focusing on these other tasks that maybe not that much fun to kind of dig in and build solutions for. So just as we start to wrap up, is there, looking towards the future, are there trends or advancements that you're seeing in the field of, data observability and reliability that are exciting to you?
So data observability is always fun because it's kind of it's a relatively new category, and so and we're fortunate enough to be on the kind of bleeding edge and kind of constantly define and reinvent it, which is a lot of fun personally. I'll maybe touch on one trend that is probably top of mind for everybody. But if you're not living under a rock, you've probably heard of generative AI and all of that. I think it's going to have interesting implications for our space as well. There's probably three different ways that I see it. One is I think generative AI is going to unlock a lot of use cases in data. I think people are going to be able to access data with natural language. It's going to happen in baby steps. I don't think we're all getting replaced by models tomorrow, but it is going to make data more accessible to people and organizations. That people that used to have to ask for a favor from an analyst or tediously work to create a dashboard on their own, they'll now be able to basically ask their question, get an answer. I think similarly, data engineers are going to be much more productive. They're going to be able to automate a lot of their work. They're not going to be replaced, but they're going to write their SQL and their Python faster and better. And so I think if you think about that, the outcome is there's going to be more data products. There's going to be more data usage. It's going to be used in more use cases. And that will make data observability even harder because we're going to have more complex systems. And even more important, right? Because there will be less governance, right? There will be less gatekeepers that take a look and crunch the data before it gets used by consumers, right? And so data observability is just going to become more important. I think the other aspect of generative AI is that, I think people are going to use generative AI in their own businesses, right? All these companies that we talked about, they're going to find great use cases for generative AI, and they're going to build data pipelines that either run these models, or for some companies, it might make sense to even fine tune or train models, right? And I think it's going to be interesting to see how can we help make those pipelines reliable? How do you make sure that those LLMs do what they're supposed to do, right? There's no shortage of examples where they don't do what they're supposed to do. And so, that'll be really interesting to follow. And then finally, I think like everybody, we're looking at how generative AI can help our users do their work better and faster, right? And how it can integrate with the workflows around detecting and resolving and preventing data issues. And there's some exciting stuff coming down our pipeline. And so, overall, it's a very exciting technology that I think is going to be really interesting for the world and for data observability in particular.
Yeah, absolutely. Awesome. And Barr, do you have anything you want to add to that?
I can just share an example of a company that's, thinking being pretty thoughtful about both sort of data BI and AI use cases. I mentioned JetBlue earlier. It's just a little bit of that story. So JetBlue, folks know, sort of a leading international airline, and their data team actually manages all the company's data from sort of bookings to flight times. And, as they're sort of getting more sophisticated with using data, they're actually the biggest, I think one of the sort of biggest dbt instances. So they have thousands of models. And with sort of dbt and Snowflake, they just sort of accumulated a ton of value, and the use of data exploded internally. And so they started having sort of a team that was actually called Eyes on Glass, which would manually refresh dashboards to make sure that the operations are smooth and everything is sort of working accurately. Just because, as you can imagine, having reports or data go wrong is basically unacceptable, especially for an organization that relies on data to make sure, that your suitcase is arriving on time. And they actually considered, for these use cases, either like hiring a team to sort of set up manual tests or to build an in-house solution or something like that, and ended up going sort of a more, scalable route with data observability to make sure that sort of all the operations and customer support are running well, and, investing in sort of AI use cases in particular as well. And so I think that is an example for a team who's being very sort of thoughtful and diligent. And as they're introducing more and more use cases for data and powering data across their teams, being thoughtful about how data observability can support that journey.
Yeah, that's a really great example and use case. And I imagine there's the amount of data and insights that essentially like an airline has is going to be super powerful, and they're probably only really just sort of scratching the surface there. So Lior and Barr, I want to thank you so much for being here. I feel like there was so much to unpack. We probably need to bring you back to dive in deep on a couple of these different topics. I would love that. And thanks again for being here, and cheers.
Thanks, Sean.
Thanks, Sean.